Alright, this is primarily for the vocational ed instructors for the summer of 2015. I look back at my notes, and the last time I saw that we did any kind of scope work was 2011, so I figured it was time to do a little bit more. I'm going to use the Pico scope, which is basically a computer-based platform. It lends itself very well for not only diagnosing but teaching. Everything that I take as far as waveforms, I can copy into a variety of different media, and I can save it, use it for PowerPoints or other things in the classroom. So first thing is just how to turn it on, some of the common settings, and then in another video we'll go ahead and do some actual tests. When you download Picoscope, you have the Picoscope Automotive is what we're going to use. You also have Pico Diagnosis. We're going to use the Picoscope 6 Automotive, so we'll open that up and see what happens. Alright, at this point I do not have the scope connected. I just want to show you some simple setups. So we'll save the setup for when we actually look at a crank and cam sensor. So right now it's asking me, do I want to do a demo? So I'll say yes, just so that we can see some things. Alright, what we have here appears to be an injector waveform. Now, once you make your connections, you're going to see whatever you happen to see voltage-wise on the screen. If you're lucky, your voltage levels will be such that you can capture this. As you can see, this voltage, this is set up for auto. If I wanted to change that, here are my options. If I can go plus or minus 10, you can see I've kind of zoomed out, made things a little bit smaller. To zoom in, I can decrease then the voltage, plus or minus 5. Probably as good as I'm going to get there. We can attempt to make it zoom in a little bit further, plus or minus 2. But you can see it appears that we're cropping a little bit of our waveform. We're not seeing the entire waveform. So I will go back to plus or minus 5. Okay, now you can see that this is jumping all over the place. That's because we're not triggered. If you don't know what type of waveform you're going to look at, it's probably best not to trigger. That way you can at least see what's going on, and you can make adjustments once you see what's happening on your screen. So right here I'm pretty confident that I have the voltage range set. I'm going to change the time a little bit. You can see I'm at 5 milliseconds per division. To zoom in, I'm going to decrease that value. So let's go down to 2 milliseconds per division and see what we get. That's not too bad of a picture right there. And if I want to zoom in even further, let's go to 1 millisecond per division. Alright, now if I want to keep this thing from traveling across the screen, my next choice is trigger. So if we come down to the trigger, you see it says none there. I'm going to go ahead and hit the drop down box. You can use auto trigger, repeat. Stay away from single unless you're looking for some type of glitch. I'm just going to hit the repeat. Now you can see I've got a problem here. I have no pattern. The reason being is that this is my trigger point, my trigger threshold. I know that I was running somewhere between 1 and 2 volts or so. What I need to do is to locate that somewhere within the range that I expect to see. So I'm going to move it over here, time-wise and voltage-wise. Once I release it, now I've got a good pattern. Now, if I wanted to back out, to zoom out a little bit, I would change my time increments. I would increase them so we can see what else is happening, and not much there. Am I going to get another picture here? Let's try 5 milliseconds here. Still not much more. Let's zoom out a little bit more. Let's go to 10 milliseconds. Okay, well, from here we can determine a few things. If we look at the boxes, we can see how many milliseconds occur between each occurrence. I'm going to go ahead and change my offset here just a little bit. Now, there's my zeros. Okay, so we can see this is where the trigger's occurring. This is where it's occurring again here. So it appears that I have 60 milliseconds occurring in between these events. A little bit about the trigger. I'm on the rising. If I wanted to trigger on a falling slope, I could just change that. Nothing really apparent happened here. Let me use my trigger point. I'm going to decrease him. We're just going to lower him down on the voltage, so the threshold voltage is a little bit less than what it was. There we go. Let me change my offset again so my zeros line up for me. Okay, and again, nothing's changed, 60 milliseconds between events. But you can see that I've triggered on the falling waveform, and my trigger in this case is somewhere around half a volt, or it's saying here less. Now I'll show you triggering on the rising waveform. It just kind of sets the offset, if you will, one way or another. I prefer to trigger on what I know to be the on point. If this truly is this would be where it is turning on, so I'll use a falling trigger. Now you may say that the voltages are all off for an injector. That's true, but again, this is just a demo. It's just giving us something that we can zoom in on. We can change our settings and take a look at that. Real world, we'd be seeing in some cases upwards of over 100 volts for this little spike here. Okay, relatively easy to use, not too terribly difficult whatsoever. If you're dealing with most automotive, and that's what we typically deal with, let me just show you that there is a pretty nice menu here. I can look at charging and starting systems, sensors, actuators, ignition. Let's look at actuators, since this is what I assume to be an injector. Right over here we've got injectors. Now this is a British-based company, so it's not gasoline, it's petrol. Multi-point voltage, that'd be what we'd be looking for. If I clicked on here, it is going to give me a little bit of information how to set it up. Some example waveforms and notes and any applicable technical information. You can scroll down through here, take a look again what the setup is, example, and again some of the other information there. So again, pretty nice, actually pretty intuitive. Once you have all of that taken care of, and close the window. Now, if we take a look here, we can see that the trigger is not quite where it needs to be. The other thing I need to mention is that oftentimes when we set this up with a trigger initially, it may not record. So a little green arrow, that's recording. The red dot is to stop. So I'm going to move him up just a wee bit, and we'll hit start. Alright, notice I picked pretty much nothing up because again our waveform was relatively small. This menu has selected the actual values that you would use if we were looking at an electronic injector on a running engine. So moving the trigger point down to where it was, you can see that the manufactured waveform here by our demo is not playing well with the settings, so we'll go back and choose ±5, and then back we are. Okay, so again, nice, relatively intuitive, something students can pick up on relatively quickly, something very useful for classroom explanations, demos, presentations, what have you. I like it. I use multiple scopes, but for the classroom this is one of my favorites. So I'm going to end this, and the next video hopefully we will see this scope being used to look at some sensors, both voltage and possibly looking at some current ramp as well. That's all I got.